side of the equation at a time, it is often better to work with the more complicated side first.
All right, pick the icky side. Number 2.
Look for opportunities to factor an expression, add fractions, square binomial, or create a monomial denominator.
All right, so like we've been doing, we factor things when we can. We have a monomial divisor like 82 that we were supposed to go over. All right, number 3.
Look for opportunities to use the fundamental identities. Note which functions are in the final expression you want. Sines and cosines parallel, as do secants and tangents, and cosecants and cotangents.
All right, so we're going to be using these 3 things again. All right, we only have to memorize sine squared plus cosine squared is equal to 1. How do we get the other 2? Divided by sine squared and cosine squared. All right, number 4.
If the preceding guidelines do not help, try converting all terms to sines and cosines.
Change everything to sines and cosines, especially if they're singular powers. All right, and number 5, my favorite. Here we go.
Always try something, even paths that lead to dead ends, provide insight.
All right, so when you just start looking at it and you're not doing anything, you might want to try something. All right, even if you run into a dead end, great. You know that's not the way to go. Okay, all right. Secant squared theta minus 1 over secant squared theta is equal to sine squared theta. Again, we're going to pick the icky side first. Which is the icky side? The left or the right? The left. All right, so let's work with the left side. Now, there's many ways to Tampa today, and I'm going to let you choose which way you'd like to go. What would you like to do? Okay, use a trig identity. What's it going to be? Okay, so the top is tangent squared. That's what we're doing? All right, so let's change the top to tangent squared. So now I have tangent squared over secant squared. Okay, now what? Convert everything to sines and cosines. So what's tangent squared? Sine squared over cosine squared. Now, if I divide by a secant, that's really multiplying by what? A cosine. So this is now going to be cosine squared up top. So what happens? Cosine squareds cancel. So what are we left with? A sine squared is equal to a sine squared. And that's what we wanted. All right. Now, when I get to grade these sometimes students go like weird ways to Tampa, and then magically they just go there. All right. Now, is it going to equal each other every single time? Yes, it will. Every single time it will equal each other. That's what we're doing. Okay. The crappy part is that I have to grade the middle stuff. All right. So you can't really skip steps in these. I'm grading your work. Okay. I'm grading your thought process. Okay. All right. All right, which side would you suggest I work with? The right side. That's the icky side. All right, so let's work with the right side. What should we do? How do we add things together? We need common denominators. What's going to be this common denominator? 1 minus sine alpha and times 1 plus sine alpha. So what does this left fraction need? A 1 plus sine alpha. So now I have 1 times 1 plus sine alpha. And then what does this right fraction need? 1 minus sine alpha. So now I have 1 times 1 minus sine alpha. Now what? Okay, we distribute the 1. All right, so that's good. Now what? We combine like terms. So what do we get up top? We get 2. All right, the sine alphas cancel up top. So now I have 2 over. What should we do to this bottom? The other F word. Foil. All right, so what does it foil to? 1 minus sine squared alpha. All right. Now, do we notice anything? The bottom's a trig identity. So what is the bottom? Cosine squared. So now I have 2 over cosine squared alpha. Well, what is 2 over cosine squared alpha? If I have cosine on the bottom, that's really a what? A secant. So this is the same thing as 2 secant squared alpha. And do they match up now? Yay. All right. All right, what do you want to do? You want to do the left side? All right, what are we going to do to the left side? You want to do trig identities? Okay, so what is tangent squared plus 1? Secant squared, so let's change it. And what is cosine squared minus 1? Cosine squared minus 1 is not sine squared. It is negative sine squared. All right, so this is actually negative sine squared. Okay. Now what? Convert them to sines and cosines. So what is secant squared? 1 over cosine squared. I have 1 over cosine squared times negative sine squared. All right. So what do we have? Negative sine squared over cosine squared. And what do we know that is? Negative tangent squared. All right, did we get there? Yes. Yes, we did. All right, pretty good. All right. I'm probably going to guide you a little bit on this one. Right. Which side is the ickier one? The left is. The left is ickier, and here's why. What's harder to do? Is it harder to add something or harder to multiply something? Add. Why? Because you have to have common denominators. Multiplying, what do you get to do? You just get to multiply straight across. All right? But in addition, you have to have, or subtraction, you have to have common denominators. Okay? So that's why I'm going to lead you to choose that side first. Okay? All right. What should we do? All right. So what's tangent? Sine over cosine. All right. What's cotangent? So again, what do we need? When we add fractions, what do we need? Common denominators. What's going to be my common denominator? Cosine x times sine x. All right, so what does this left fraction need? A sine x. So what does it become? Sine squared. All right. What does this right fraction need? A cosine. So what does that become? A cosine squared. Well, what did we get? We got a trig identity up top. So what is that? It's 1. So now we have 1 over cosine x sine x. All right. And what is that? That's secant cosecant. All right, so this is the same thing as secant x cosecant x. And do they match up? Are they going to match up every time? If you do it right, they will. All right, if you don't break math rules, you'll get to Tampa. All right. Which side we want to work with? Which side? Left side. You going to work with left side? All right, let's work with left side. What are we going to do to the left side?
Sine and cosine.
Sines and cosines. So what's secant? 1 over cosine. That's the technical. All right, what's tangent? Sine x over cosine x. All right. Well, this one's kind of nice. What does it have? Common denominators, so that's cool. So now we have 1 plus sine x over cosine x. Now, usually you don't do this step, but we've kind of been stuck in a hard place here. What should I multiply this by?
Reciprocal. No.
Not the reciprocal, but the, starts with a C. Conjugate. We're going to multiply by its conjugate. Now, normally, I would probably work with this right side. What would I start out multiplying by? 1 plus sine over 1 plus sine. All right? Just like what you were supposed to do in number 82, that's kind of what we do. But in this case, we're going to kind of like put the thing on the bottom. All right? So we're going to multiply by what? 1 minus sine over 1 minus sine. So what does it become up top? 1 minus sine squared over cosine x times 1 minus sine x. All right. Do we notice anything here? What's the trig identity up top? That's cosine squared. So now I have cosine squared x over cosine x times 1 minus sine x. What could happen here? Get rid of a cosine. All right, get rid of a cosine. So now I'm left with cosine x over 1 minus sine x. I'll let you choose either one. However, hopefully you choose the right one. All right, or the correct one, I should say. All right, which one should you probably choose here? The left one. The left one's a little ickier. All right, now why is the left one ickier? I really want to talk about that. Why is the left one ickier?
Because it's not separate.
What?
The addition's on the bottom.
Good. All right, it's a binomial on the bottom. All right, it's a binomial in the denominator. That's the icky one. Okay, that's really the reason why. It doesn't really have to do with cosecants and tangents or sines or whatever. It's really about a binomial on the bottom. All right, so what can we do? We're going to work with the left side. So what do you want to do? You want to multiply by a conjugate? We can multiply by the conjugate. Ooh. This thing. All right, so what's my conjugate? 1 minus cosecant. And then I have, forgot a C. 1 minus cosecant theta. All right. So up top, I'm just going to leave it as cotangent squared times 1 minus cosecant theta. And then what's going on the bottom? What's going on in the denominator? What do I get? 1 minus cosecant squared theta. All right. All right. Now what are we going to do? What does 1 minus cosecant squared go to? Negative cotangent. This can be replaced by negative cotangent squared. All right. So now I have a cotangent squared. And then times 1 minus cosecant over a negative cotangent squared theta. So what happens? What happens? Okay, so cotangent squareds cancel. However, what do I need to be worrisome of? The negative. All right, so now I have a negative 1 minus cosecant theta. What would I highly suggest you do right here? Distribute this negative. Before I forget about it, let's distribute. All right, so now what? What is cosecant? 1 over sine. So now I have negative 1 plus 1 over sine. Well, what do I want to think of that 1 as? I need common denominators. It's sine over sine. Exactly. So when I make them common denominators, now I have a negative sine theta plus 1 over sine theta. All right. Negative 1 is the same thing as like negative sine theta over sine theta. All right. Anything divided by itself is 1. All right. So I just changed negative 1 to negative sine over sine. And so then they'd have common denominators, and then they match up. Okay? All right. 3 through 30, I would like you to do 3 through 35 odd. All right?